Hello viewers. In today's session, we are going to add new worker node in Kubernetes cluster to an existing single node cluster. Okay, so this is basically Ubuntu environment. So let me show you. Yeah, in today's agenda, we need to add new worker node using the token. Then we need to, we can see how the scheduler is redistributing the existing pods across the all clusters of the node. Okay, so in my lab environment I have one cluster is running, so this one VM, so it is virtualbox environment. So I installed Kubernetes version like 1.32 on Ubuntu, and this machine is running. Okay, let me log into that machine. Yeah, so I already log into that machine. You can double check. These are the Kubernetes version I am running 1.32.5, and this is single node Kubernetes cluster. Okay, this node is act as control plane and the worker node. Okay, and the node IP is .26, and your API server is running on this .26. Okay, so before we adding this new worker node, so let me check what are the pods are running here. Yeah, okay, get pods -a. You can see all pods. These are the system pods. You can see these are the system pods. I am using Calico as the CNI plugin, network plugin. So that's why, as there is only one node is running, so that's why only one pod is running here, Calico node. Okay, so we expect when we completed the adding the node, then we expect another pod should be running like Calico node, second node. So second node. Okay, so before that, we can see what are the user application is running. You can see one user application is running, that is a Nginx application is running, and this deployment have two replicas. Okay, so you can check the deployment also. OC get deployment -n, then namespace demo up, and you can notice here both the replica are running on same node because it is a single node Kubernetes cluster. Okay, so once we add a new worker node, our expectation is the scheduler should redistribute the workload to the second node also. Okay, that is one pod is running on first, that is the first VM, and the second should be running on the Kubernetes worker node. Okay, so you can see my master node address is .26, and I am going to add a second worker node, that is IP address is 31. Okay, and the master node have minimum requirement like 2 CPU and 16 GB of memory is okay, or 8 GB also fine, but worker node 1 CPU also fine, 4 GB RAM also fine. Okay, let me create one new virtual machine in Ubuntu, here in VirtualBox. So I already created this new virtual machine KW1, that is worker 1, and the system configuration you can see, and the network similar like master node. First one is the network, and the second one is the host only. Okay, so let me start this machine worker node. Yeah, so the first thing is that we need to generate this token. Okay, so when you perform the kube-init command, when you install the command, installing the control plane node, so first time at the end of that kube-init command, it will show you like some join token. Okay, like I'll show you. I have some earlier videos are there, or might be that output is not here. I can show you the command. Okay, one second. Yeah, this command, the kube-init. Basically, when you install the Kubernetes cluster, that time it will show you like these are the join command you can execute on the worker node, so that the worker node will be joined to the existing cluster. Okay, so since I already installed that one, so I forget that command, so we need to print that command again. Okay, so these are the command kubeadm token create print join command, so that it will show the existing so that should be executed in the master node. Okay, kubeadm token create print join command. Okay, now it is showing the join command. Okay, these commands should be executed at the worker node. Okay, so let me check whether worker node is successfully rebooted. I mean, bring up the worker node. Yes, you can see the prompt like kw1 login prompt. Okay, let me log into that machine using the SSH. One second, let me create new session and log into that machine. Okay, and that is k worker1. Yeah, now we are in k worker node, that is the new node. We are going to add this node to the existing cluster. Okay, so we need to execute that command, that is the join command, which is generated in the worker node. You can see this join command, you need to copy this one and execute on the worker node. Okay, now before that, one more thing I can inform you, like all the necessary package should be installed in this new worker node. Okay, I have provided all this in a shell script file. You can see all the packages should be installed here. Okay, up to this one. Basically, these are the steps which is required, the mandatory step to install all the Kubernetes packages in the Ubuntu machine. Okay, so my first video, I mean, when I installed in another video, when I installed Kubernetes cluster, single node Kubernetes cluster in Ubuntu, I covered all this step. Okay, you can follow that video also. Okay, so I documented, I mean, created one script, so that all you need to pass the parameter like which version of Kubernetes you want to install. So in my case I am using 1.32. You need to pass the parameter only to the script. Okay, then the script will install all the packages in the worker node. So this part I already covered in this machine. So now it's checking some pre-flight check, and make sure you enable this necessary port, otherwise, I mean firewall port, otherwise you can disable this firewall. Okay, because during this node join it will check like a different port, it need to check to communicate internally. So you need to disable this one. Because it's a lab environment, we can disable this port, I mean firewall. Yeah, now it's progressing. Basically in this stage it will restart, I mean install this, I mean restart this kubelet service, so that this kubelet service will, I mean kubelet will internally communicate with master node API server to create one connection, I mean to join to that existing cluster. Okay, so I think now it's completed. Then we can check there Kubernetes get node, kube control get node. Now we can see the node is joined, but now it's the new node is joined, that is k worker 1, but now it's in not ready state, so it will take some time to get it to come to ready state. Okay, and finally you can check one thing, like in get pod -a one Calico node should be come off. Yeah, earlier we seen like this is the first Calico node is there for the first node, that's the master node. Now we added one worker node, so that expect should be like one Calico node should be bring up, should be in running state. Okay, once it is running state, most probably it node status should be in ready. Okay, so basically it will pulling those Calico packages, I think, on that node. That's why it's delaying. We can wait. Now you can notice the second Calico node is ready, in running state. Okay, so hopefully the get node command should be ready. Yeah, now we can see the second node, the new node is right now in ready. So we can check get node -o white, so that it will show the IP address. Okay, so now you can see our existing cluster was .26, that is the master node IP, and the new node IP is .31. Okay, so but one more thing you notice, like the node role is earlier the control plane node, but we expect this node should be worker node role. Okay, so for that we can use one command, this node we can label the node. Okay, label node your worker node name, you can see here worker node name, then node role should be like worker. Okay, so I executed this command. Now we can double check this. Now we can see the node role changed to worker node. Okay, hopefully all the pods should be in ready state. Yeah, running state. Yeah, now we can see this demo up. Okay, so earlier the demo, all the the replicas are running on the master node only. Okay, as earlier it was single node Kubernetes cluster, but now it's two nodes are one node is added, so the replicas should be distributed among the node. Okay, we can double check this one. Now we can see still the replica is running on the same node like the previous master node. Okay, so now once we restart this deployment, we can check the deployment also. Okay, deploy -m demo up. Now we can see one replica is deployment is there, and two replicas are there. Okay, so that's why two number of pods are running. So we need to restart this deployment, so that the scheduler will distribute the workload among the worker nodes. Okay, so our expectation is like the one replica is running on first node, that is the master node, and the second replica should be running on the worker node. Okay, let me restart this replica. So how to restart this deployment? This is the command, kube control rollout restart your deployment name. Okay, kube control rollout restart your the deployment name and your namespace. Okay, you can observe like all the pods will be restarted, and the scheduler most probably will schedule on different nodes. Now it's restarted. You can check the status using rollout status. Now you can see that waiting for rollout to finish, 1 out of 2 new replica has been updated. Okay, so parallelly you can check the pod status -w, that is the running status. You can check. Now you can see the second container, the second replica is one they deleted, and it is container creating. Okay, so initially it will like pulling the image on the new worker node, so that's why it is sometimes it will show like Meanwhile it will show like error, image pool or image pool backup, those kind of error is coming. But let internally it will pulling those images in the respective worker node. Okay, you can check the logs like get event, then your namespace. Okay, you can check all activity what's going on there. Okay, now you can see it scale down from that 2 replica to 0. Now it going to scale up first 1 to 2. Okay, so all these things you can see success. It is pulling the nginx image on the second node, that is the new worker node, and it is showing like successfully pulled that image. After it is pulling that image, then it will bring up that pods. Okay, we can monitor that one, get pod. Yeah, so now both the replica are in running state, and we can check on which port, which node this replica is running. Now we can see the things like after the restart, the scheduler is redistribute the workload among the all nodes of the cluster. Now we can see the first replica is running on the master node, and the second replica is running on the worker node. Okay, so now successfully added this node, and you can also delete, remove that node. So I will cover that part also, how to remove this node, this new worker node. So for that you need to first drain the node. Okay, so you need to drain that node. I think so, yeah. Yeah, you need to drain that node, cube control drain your worker node and ignore demonstrate. Okay, so now yeah, you noticed one thing. When you drain that node, one of the additional step it is automatically executed, that is it will curtain that node. Okay, so that the scheduler will not schedule any pod on the worker node or that specific node. Okay, we can check that node, get node status. The node status is ready, but it is scheduling disabled. Okay, so that the scheduler will not allow to deploy any of the new pod on that node. Okay, now in the drain node, what happens internally, all the pods are evicted from that node to rest of the cluster. You can see evicting the pod because two replicas is running. So one of the replicas should be the replica which is running here in the worker node, the same, that is the here you can see nf. Okay, this replica should be redeployed to master node. Okay, because that is only single node is remaining. Okay, so now it's safe to delete the cluster. This is the command, kube control delete node. Now our expectation is only one node should be shown. Now you can see the changes, only one node is showing, but to completely remove the that node, we need to execute, we need to reset that one in the worker node. Now I log into the worker node, you can see worker node, then you need to execute kube-pkgs reset. Okay, this command, so that we can completely remove this, unconfigure this worker node from that cluster. Okay, now it's deleted, that's why it is not showing in the master node. You can see that that worker node is not showing here, but we can unconfigure this kube-pkgs. Okay, kube-pkgs reset. Yes, so we can also delete this one, this some existing configuration. Yeah, so now this node is completely removed from the existing cluster. We can shut down this machine also, not required. Okay, yeah, now it's again bring up to single node Kubernetes cluster. Okay, so this is the procedure how you can add a new cluster and how your application workload is distributed among the all nodes, and finally the clean up things like If you don't need the worker node, then you can delete the worker node also. Okay, that's it about on today's demo. We'll see you on next video. Thank you guys.